Okay, example 2, JAM 1982. Okay, so this is the manometer. Okay, let's go down and read the questions. The water manometer shown above is measuring the pressure of the gas supply. Full stop. Take note of the word water. If the specific gravity of Mercury, take note of the word specific gravity of Mercury. There are so many terms I'm going to be explaining here, so you just stay tuned to the end of the video. Is 13.6, and the atmospheric pressure is 70 centimeter. Okay, of mercury. Of mercury. What is the total pressure of the gas? That is gas pressure in centimeter of water. You can see that there are two liquids here. We have mercury, we have water, and we are asked to look for that of water. We know that the gas pressure, I've started solving already. Small letter p as gas supply equal to capital letter P atmospheric pressure plus height. Okay, so let's take a look at everything that was given to us in the question. Okay, so gas pressure, that is what we're looking for, comma, the atmospheric pressure is given to us in the question, 70 centimeter of mercury. The height is what? 3 centimeter. Now we can't, so many students will be so quick to say the answer is 73, but that's wrong. We're asked to find the gas supply in centimeter of water. So what we are looking for is this pressure. This atmospheric pressure of water is unknown. We're not asked to look for the gas supply in centimeter of mercury, but of water. So how do we now solve it? In physics, there is what we call relative density. Relative density is relating any other substance to water. It's a constant formula. Relative density is relating any substance to water, and it has a formula. My relationship with Ernest, I call him my brother. Do you understand? That's how we relate. He's related to me as a brother. You understand? So now, how other substance relates to water is what we call relative density. Now, relative density equal density of substance over density of water. So if I ask you what is the density, what is relates Coca-Cola to water, you tell me relative density equal density of Coca-Cola over density of water. Do you understand? So now the substance here that we're looking at is mercury. And then this water. The question is how do we get the density of mercury? I'm going to explain how this relates. Mind you, what we're looking for is the atmospheric pressure of water. Now, since water and mercury is being mentioned there, it means that the pressure for our mercury will be equal to the pressure of our water. Now, what is that formula? Let me write it here. Oh, let's just keep solving. I'll come back and then have a recap. So let's just continue. So we want to find the density of mercury. Relative density, is it given to us in the question? We forgot to put that one down. Now look at it. If the specific gravity of mercury, note that specific gravity is the same thing as relative density. Yeah, it's the same thing. You understand? So relative density can also be called specific gravity. Okay, so the relative density of mercury is said to be 13.6 equal. We're looking for the density of mercury over. Now, what is the density of water? The density of water is a constant, which is 1000 or 10 to the power of 3. So, therefore, the density of mercury equal to 13.6 times 1000, which is equal to 13,600. Now, 13,600, what's the unit for density? The unit for density is kilogram per meter cube. Yeah. Now, relative density, I just want to chip in this. Relative density does not have units. So we ask why. It's because the density of a substance is kilogram per meter cube over the density of water is the same thing, kilogram per meter cube. You're going to see that it's going to cancel out. So that's why relative density does not have units. But someone will be asking, why is this now having units? Remember, we're looking for the density of the mercury, which is the relative density times the density of water. And that's why we're having the units there, kilogram per meter cube. Okay, and let's proceed. Okay, I've said this before, that the equivalent of atmospheric pressure, which is 70 centimeter of mercury, 70 is given to us in the question, okay? And centimeter of water is calculated by equating the pressure formula for water and that of mercury. Remember the pressure formula. Pressure formula is what? Density times height times gravity. Now, of what? Of water is equal to the pressure formula for density. Pressure formula for mercury. Times height times this of mercury. So let's do this. So density of water times the height of water times gravity equal to the density of mercury times the height of mercury times gravity. Gravity is a constant, which is 10. So let's substitute all the formula into this. Now, do you now see that all we've been looking for was the atmospheric pressure for water? And how we get that is to equate the pressure formula of water to that of mercury. Now, looking at this, what is the density of water? We know the density of water is 10 to the power of 3. And then the height of the water is what we're looking for, which is the same thing as the atmospheric pressure times 10. That's if G is given to us as 10. Now, look at it now. Look at it. Very, very interesting. Now, the density of mercury. If we had written this down, then we need to go back and calculate the density of mercury. And how do you calculate the density of mercury? The density of mercury is not given to us, but we know that the density of water is 1000. And the relative density of mercury is given to us. So from that three statements I just mentioned, relative density of mercury, density of water, two things are given to us. Just one unknown, which is the density of mercury. And that's what we've calculated there. So I'm going to write it down. That's 13,600 times, what is the height? I told you the height is the same thing as the atmospheric pressure, since they share the same units. So, which is 70 times 10. So, to calculate the height of water, which is the same thing as the atmospheric pressure of water, it will be equal to 13,600 times 70 times 10 over 1,000 times 10. Okay, this cancels this cancels this cancels this cancels this. Okay, and then we are left with, let me see, 1,360. No, I'm making a mistake here. This and this. Aha. So, sorry for that. 136 times 7, which will give us 952 centimeter. Now, we've gotten the atmospheric pressure of water. We can now bring it back to our formula. So, P equal to, what is the atmospheric pressure? This of water is 952 centimeter plus the height is 3 centimeter of water. Okay, so that would give me 955 centimeter of water. If the question was, what is the gas supply in centimeter of mercury, we don't need to go through the stress, because that is already given to us. But the asking of that of water, so we now need to relate water with mercury. You understand? So, and how to relate any other substance with water is to use specific gravity, which is the same as relative density, and that's what we've done. And then we did that to get the density of mercury, which we can use it to get the atmospheric pressure of water when we relate the gas formula together. And that's what we've done. And then we got the atmospheric pressure of water, and then we equate it into the formula, which is gas supply is equal to atmospheric pressure plus the height, which is the same thing as the column of the height of either water or mercury. So we've come to an end of this. I'm going to just drop some assignment question. You can answer it and then leave your answer at the comment side below. Please like this video and share it to other students. God bless you. Right, so this is the assignment. This is actually exam question 1994. Right, so this is where the gas supply is, and then we're given this height in centimeter. This is 3 centimeter in diagram above. If the atmospheric pressure is 760 millimeter, what is the pressure in the gas chamber, which is capital letter G? Okay, so solve it and then leave your answer at the comments side below. Thank you.